Hello and welcome to this demonstration of the SERPAC Structural Suite toolset introduced in SERPAC 6.9. The Structural Suite tools are located in the Database menu and the Structural Suite submenu. The first function that we're going to look at today is the Data Visualizer. With this function, a drill hole database should be open. This database should contain your structural measurements inside point or discrete tables. For example, if you have surface samples, maybe recorded at the outcrop for bedding plane, joints or foliations, or fault planes, you may have a discrete table. That discrete table will have sample ID and coordinate information, and then for the Structural Suite toolset should have dip direction and or strike. If, for example, your structural measurements were downhole, then you would need a point table, and that point table will contain hole ID, depth 2, and should also contain dip direction, dip, and strike. So now we'll look at the Data Visualizer function. On the first tab, Data Source, we need to select the table in our database that contains our structural measurements. And we have to select the field that contains our dip, and then depending on whether we have strike or dip direction, we can choose either. We will select the field that contains that azimuth information. So in this example I'll choose dip direction. Once you've selected the direction field and dip field, we can then, if we want to, constrain on any field in the discrete or point table, and any field, if desired, in the collar table. On the Symbols tab, we have two ways of controlling the style of symbol that we're using. For example, circles, diamonds, etc. We have simple styling. So for example, if I want to choose circles, I'll pick an appropriate scale value, and I can then display that either as 3D circles or 2D circles, depending on my preference. If you want to use the advanced styling, that requires you to select the field that you want to classify your symbols by, for example dip, and you'll set up your different styles. For example, I'll choose circle and diamond, and I may want to say any symbol that has a dip less than 30 display as a circle, any symbol with a dip greater than 30 display as a diamond. There are more advanced expressions here, and I can provide them if you wish. So under simple styling, just for the purposes of this demo, we'll choose circle and symbol scale of 30 with 3D symbols. On the Colouring Styles tab, we can select a field to colour the symbols by. For example, I'm going to choose dip. Now if you only want a single value for your single colour value, for your symbols, for example, if you want them all as red, currently the best way of doing that is to delete the fields within the function, and for example to say colour all symbols that have a dip greater than -999, and then all the symbols will be red. Alternatively, you can leave it on the default colouring, which will colour symbols individually by their associated dip classification. So we can now proceed and run the function, and it will generate our structural symbols as circles and colour them by their individual dip. Okay. Once they are displayed in SERPAC, you can then bring in additional information such as contours and or DTM surfaces to display and see whether you can see any correlation with your other pieces of SERPAC data for doing your geotechnical assessment. We'll now use the Data Visualizer to display downhole structural measurements. So I'll choose my point table, the direction field and the dip field, and I'll set an appropriate symbol for showing the structures downhole. this example, I'll use 3D symbols and color the symbols by dip. Depending on how many structural samples you have, this will be quicker or slower. Once that's finished processing, you'll now be able to see your structural symbols downhole. So around each hole and each sample downhole, we can see an octant shape showing the trend of the bedding plane that also roughly matches the trend of the surface measurements that have also been taken. As well as bedding planes, foliations, you may also want to use the structural suite and the data visualizer tool to display faults. So again, following a similar workflow, this time I'll choose, I've got a square symbol, so I'm going to use that. And with the fault symbol, I'm actually going to color it by a field that I've put in here called fault, that colors it by the different fault numbers. And now we can see here these symbols also allow us, as well as looking at bedding planes or foliations, can give you an idea of your different faults and their directions. So one question that you might have is, with the data visualizer, how do I load custom styles into the data visualizer? So they are located inside your standard C drive users, public, Geovia, Serpac, your current beta version that you're working on, the share folder, resource, scripts, and there is a subfolder there called structural suite. Inside of there you've got a subfolder called symbols. These symbols, for example if we take the circle, are positioned so that the center of the symbol is located at 0, 0, and the approximate radius of the symbol is 0.5 meter. So using that information you can create your own symbols. For example, in this data set I've made a typical strike dip symbol, and when you save that as a string file, you should save that so that it retains the name in the purpose field. Why is that important? Well, that purpose field will get saved into the string file here, and that is the name that will appear in the structural suite menu. Okay, so moving on from the data visualizer, let's now look at some of the other functions. So now let's look at one of the other main functions in this release, which is the stereographic projection. To be able to visualize that, we first of all have to use the data visualizer to display some of our structural data. So I'm just going to display the surface bedding plane measurements again. So once we've got our structural measurements displayed on screen, we can now use the structural suite create stereographic projection from selected data. This allows us to click and drag a polygon around part of or all of our structural data. Press escape when you're happy that you're going to make a polygon, and it will close the polygon, and then extract the samples from within that polygon and display them on a stereo net. So these disks are dipping approximately 10 degrees south-southeast, and are plotted correctly on this stereograph projection as shown. What you can also do is, with the stereograph tools, you can also create a single plane from the collection of samples that you've got on here. So this will essentially create a best fit plane of all the samples on your StereoNet. And what that has done is it will have created, if you see this symbol here, this is below the topography, and out of those samples that I've selected inside this polygon, that essentially is the best fits sample that represents the general trend of all of those samples within that polygon. Okay, so now let's look at some of the other functions that are available. The next function in the structural suite we'll look at is how to manually create a symbol. So first of all, we'll need to display some topography data or spatial data where you want to create the symbol. Go to the structural suite, manually create a symbol function, select your symbol that you wish to use, the string number that you wish to apply, the dip, and dip direction. You may also want to select a location for the symbol, then press escape on your keyboard and apply, and the symbol will be generated. Editing the styles can control whether that symbol is filled or has certain attributes in its display. So now we'll look at the next function, how to generate DTM gradient data. So before we run this, we'll need a DTM displayed in the graphics, and then we can start the function. On activating the function, you'll need to click on the DTM and modify these settings at the top of the form if you wish. In this example, I'm going to leave them as the pre-generated values, and then we have to decide whether we want the output as string file or CSV. String file if you want to use the output with styles functionality, or CSV if you want to use it with the data visualizer function we've previously looked at. So in this example, I'm going to export it to CSV data. And what that will do is place a grid over the data and extract the dip and dip direction of the samples at those points. So if we have a look at the resultant file, we can see that we have sample ID, XYZ, dip and dip direction. That data can then be imported back into the database providing you have a table already set up to store that information. In this case, I've used a discrete table. So if I import that into the database, I can now use the data visualizer to display that information. And because it's showing the dip and dip direction, I'm going to display this data using an arrow. And I'm going to color each arrow by its dip. Okay. So to make this a little bit easier to view, I'm also going to add transparency so that we can see the DTM data and the arrows. So the next function that we're going to look at inside the structural suite is how to locate a drill hole. So first of all, to use this function to its to its potential, we're going to display our drill holes on screen. And one common problem you have with drill holes is often you want to find a particular hole ID. It's difficult to scan that visually on the screen or to use a drill hole constraint. So this new function, locate drill hole, aims to make that a little bit easier. So by clicking the refresh button, that will pick up all of the drill holes inside your database. And if you want to find a particular hole ID spatially, you can select that hole ID. And what the function will do is add a marker on top of that drill hole ID. So if I click apply now, and then zoom all, you'll see that that's now placed a marker over that particular hole. So it allows you to find the data or the particular drill hole really quickly, which can be useful if you've got hundreds or thousands of drill holes on screen. The next functions that we're going to look at are triangle info and dip direction from 3 points. So to look at this, I'm going to display our DTM and focus in on a particular triangle of interest. So then let's look at triangle info. So very simply, you start the function and you click on your triangle of interest, and it will export the vertex, area, dip and dip direction information of that associated triangle into the message window. Press escape to cancel the function. The next function, dip and dip direction from 3 points, if we engage that function and click 3 points, it will then also give us the dip and dip direction between those 3 points into the message window. Again, press escape to cancel the function. The next function we're going to look at inside the structural suite menu is going to be fit plane to selected points. So for example, you may have a DTM or an RGF file that maps your geology or fault planes. And what you might want to do is map that plane of weakness spatially in 3D. Could be a pit wall as well, or any sort of mapped face. So to do that, we'll go to the structural suite menu and fit plane to selected points. So this is quite nice because it allows me to, for example, track the contact. And as I track the contact up over this hill, you'll see that the plane, press escape to cancel, will generate accordingly and give me an idea of that joint in 3D, or in this case, minor fault. Okay, so I can continue as well mapping more of these in 3D using the same function. Okay. So for example, I know a fault is running through this this gully here. So again, I can do the same plane of weakness, and over time generate more of these until I've mapped out the planes of weakness. Alternatively, in this example, I could also use it for mapping bedding planes. So the next function we're going to look at inside the structural suite is fit plane to selected DTM or solid. So first of all, we'll need to bring in a particular surface or solid. So to show this relatively quickly, because it can take some time with solids that contain hundreds or thousands of points, I've just got the simple SURPAC demo data solid, and I'm going to go structural suite, fit plane to selected DTM or solid, and click the associated trisolation, and the structural suite will then calculate the dip of that solid and trend of that solid, which is quite a nice feature. It will also output the best plane fit information into the message window. So we're now going to look at some of the functions for moving and rotating our structural symbols. So first of all, I'm going to use the function rotate segment by dip. So I'm on snap to plane. That allows me to click and freely drag and rotate the dip of our structural symbol. And press escape to cancel. The next function I'm going to look at is how to rotate segment by dip direction. So for this I'm going to put the data into plan view first, and then go to rotate segment by dip direction, and then again this allows me to rotate the symbol based on dip direction. Again, it's a free drag sort of function. So the next function that I'm going to use is the move segment by middle point. So if I click on our structural symbol and select where I want to move it from and to, it will move by that on that bearing and distance, by that amount. To round up this overview of the structural suites, we're just going to look at the last couple of functions that I'm going to cover in this session, which is fit plane to segment or fit plane to string. They both work in a similar way. So for example, you might have a geological map or some data where you want to digitize in a new layer a particular plane of weakness. For example, and these functions allow you to take that digitized segment and create a plane or a circle from those digitized points with the dip and dip direction. So if I say fit plane to selected string, it'll give you the same output with the sister function. And if I click that, you'll then see in 3D that it's now generated a plane from the dip and dip directions associated with those points. That plane can also be resized using expand segment if desired. To showcase that trend. Thank you. That's been my summary of the structural suite toolset. I haven't covered every function, but I hope this gives you a flavor for what's possible with this new toolset. Thank you very much.